Okay, good morning, good afternoon, good evening. We'll continue with our revisions even as we prepare for the upcoming exam. We'll continue. So I have that question there which says factor completely. How do I factor completely that kind of an expression? So in actual sense, what we are being told is just basically factorize. So we want to factorize completely that function or that basically expression. So as usual in grade something, so I want you to understand that, for example, if we were in grade 2, what were we talking about? There were questions which we were simply saying factorize. Let's say I have 2x squared plus 4x, and then you want to factorize this expression. What do? I'm sure without thinking, what was just happening is that you just basically go ahead and simply say, okay, 2x, open bracket, you remain with x plus 2, you close. Without thinking, you simply come up with that solution, because it is already within you, you know what to do. So now the question is, how did this solution come about when you are factorizing? Because the concept is talking about factoring out. So how did we come about with this solution? So basically this came about by first step by simply saying that locate the common factor on both cases. So I have first term and I have the second term. You ask yourself to say, what is the common factor on 2x squared plus 4x squared? So we are looking for the common item is what you are going to factor outside. So I'm not yet coming to I'm coming to this, yes, but I'm just trying to remind you basically the base of what was happening in grade 2. We simply say that we factor out. So it means 2x squared plus 4x, we identified, say, okay, 2 is common because 2 is found here and 2 is found there. So when we factor it out, we're going to factor the 2 which is of the lowest power. 2 here is power 1, but 2 here is power 2. So every time when we're factoring something, we always factor the term with the lowest power. So 2 of power 1 will be factored out, but it's not only the 2 which is common, but we are simply seeing that I can also see an x which is common. So what do? I factor out the x outside. Now the question comes in to say, who do I factor out between x squared or x? So we factor out the term with the lowest power. So x with the lowest power is going to be factored out. There is a square, there is power 1, so it means it's x power 1 which is going to come outside. Lowest open bracket. So if this is my common factor, it means we are going to divide every term by this common factor. So I'm going to have 2x squared this one divided by the common factor 2x plus 4x divided by the common factor 2x. That is why we always end up to have 2x open bracket, this goes and that goes, that goes and that goes, we'll have x plus that and that goes, we'll have 2. This is why this answer came about. So what happened was you were just basically factoring out the term with the lowest power, and then you divide throughout every term by that common factor which is outside. Then you have your solution. So with this recap, it is the same information we're going to deal with this guy. With this recap, we're going to use the same information to factor out that expression. So now, let's handle this expression. So what do I have? I have 9x power 4, 1 minus x, power 3 over 2, minus x squared, 1 minus x, power negative 1 over 2. So the concept of factoring works best by first of all identifying the common factor. So the term with the lowest power is what you factor outside. The common term with the lowest power is what you factor outside. So now every term is always separated by a positive or a negative. So how many terms do I have in this expression? We have only 2 terms. So what terms are those? We have the first term, which is this guy, and this is the second term. So observe your terms, both terms, observe them and locate your common factors. So in these terms, I'm seeing an x and I'm seeing an x there. So x can be factored out. But what power is this factor going to have? Is it a power 4 or a power 2? We said we factor out the term with the lowest power. So it will be x squared, which will be factored out. But if we look at, again, we observe, is the x the only common term we are seeing? No. I'm seeing 1 minus x here, and I'm seeing 1 minus x there. So 1 minus x can be factored out. And ask yourself again, what would be 1 minus x power have? We say the power should be the lowest power. So ask yourself, between 3 over 2 and negative 1 over 2, who is the lowest? Who is the smallest? A negative by default should be the smallest. So this becomes power negative 1 over 2. So you open your bracket. So these are the common factors now which we are dealing with. So when I open my bracket, what is going to remain inside this bracket will basically be the division with the common factor. We are okay? So what am I going to have? I'm going to have 9x power 4, 1 minus x power 3 over 2, which is this guy, the first term, divided by the common factor x squared, open bracket 1 minus x, like that. So the first term will have that, minus the second term, which is x squared, 1 minus x power negative 1 over 2, over the common term x squared, 1 minus x power negative 1 over 2. This is what I'm going to have in the bracket. Now let's simplify. So outside I still have x squared, 1 minus x power negative 1 over 2, open bracket. Let's start cancelling out common things. So x squared will go with x squared there, will remain with 9x squared. Now the concept is me dividing these two guys. How do I divide these two guys? We are simply looking at 1 minus x power 3 over 2 divided by 1 minus x power negative 1 over 2. So this is more like division of indices. Same bases. This is the same base as this one, but we have different powers. So according to indices, what usually happens when we have such a case, we always simply say that when we're dividing the same base by different powers, just grab that base but subtract the powers. So we have 3 over 2 minus negative 1 over 2. So this becomes a plus here because of a negative, so that we can have 1 minus x power, this is a plus 3 over 2 plus 1 over 2, which is going to give us 4 over 2, which is basically 4 over 2, and this is basically a 2, and 4 divided by 2 will basically a squared, which we are going to have. So it means if I divide this guy by that guy, I'm going to remain with 1 minus x power 2. And then you go to the second term, this divided by this, automatically these are common terms, will remain with the 1 there. We are factored out. But you can just ask yourself if it is completely factored out. So we are factored out, common factor is outside, and we have that remaining. So what's next? Automatically this is just okay, because if I start expanding this again, it means we're trying to violate the rule. Remember, the expression should be in a factorized version. We're trying to factor it out. So trying to expand again here is somehow we're trying to put it in a more like a complicated state. So what am I going to do? The final answer can just be written as a positive index by simply saying this is x squared, open bracket, 9x squared, 1 minus x squared minus 1. You close. A, which was supposed to be a negative index, it will come in the denominator and become a positive index, positive 1 over 2. And this should be your final solution. As simple as that. So we have factored our expression there. We are okay. So we have factored our expression. And then I will put another question there, which is also somehow similar, but this time around we will have to solve the equation. It is similar, but it is solving an equation. So I have another question there, that this one says solve the equation. What does solve the equation mean? Find the value of x in that equation. So we want to find the value of x. So now, every time when you see equations, always be able to see what kind of equation you're dealing with. There's linear equations, there's absolute value equations, there's radical equations. So this type of equation here is basically a radical equation. Radical equations, SADs, let me say so. So these are radical equations. And if you look at this equation, it's basically similar to the previous expression we're just dealing with, by which says factoring out. So a number of equations sometimes can be solved by factoring. Such equations can be solved by factoring out. So the first step here we are going to do for us to solve the value of x is basically to factor out. So solution here, we are going to simply factor the expression first. Remember, what did you say? Under factoring the expression, we look at the common items. So if I look at this term and this term, what common item am I able to see? The only thing I'm able to see is 2x minus 1. But every time when we factor out something, we factor out the term with the lowest what? Power. So ask yourself, between 1 over 2 and 3 over 2, who is big and who is small? Obvious 1 over 2 is small. So we are going to factor out 2x minus 1, 1 over 2. Open bracket. What is going to remain is the bracket, is basically the division of the first term divided by the common factor, the second term divided by common factor. So I'm going to have 3x, 2x minus 1 or 1 over 2 divided by common factor 2x minus 1 or 1 over 2 minus 2x minus 1 power 3 over 2 divided by 2x minus 1 power 1 over 2. So that when you see this which has been factored out should be equal to what? 0. So that we can later on have 2x minus 1 power 1 over 2, open bracket, this guy and this guy can go, will remain 3x here minus, when you divide this by that, we can use indices property because this is the same base but only different powers. So we just look at subtracting these powers. I'm going to have a 3 over 2 minus a 1 over 2, giving me what? This is basically a 2 over 2, which is just basically a 1. So I'm going to have 2, open bracket, 2x minus 1 power 1, closed. This should be equal to a 0. We are okay? And then from there, let's number simplify things. What is happening here? These are factors to be equal to 0. Remember how we even solve quadratic factors? If we have a quadratic factor is equal to 0, what happens? We equate each factor to what? To 0. This is the same information. So I'm going to equate each factor to 0. So the first factor will be 2x minus 1 power 1 over 2 should be equal to 0. And the other one should be this factor, which is 3x minus 2, 2x minus 1 should be equal to 0. So that when you solve for this, this is just the same as saying 2x minus 1 equal to 0. 2x should be equal to positive 1 over 2 over 2. So the value of x can be equal to 1 over 2. This is the first value of x based from the first factor. Then you deal with this guy, break the brackets, 3x minus 4x plus 2 to be equal to 0. This is negative x plus 2 is equal to 0, and negative x is equal to negative 2, and x should be equal to positive 2 when you divide both sides by what? A negative 1. And you have solved your equations without thinking. Very fast. The only concept here, you understand that this can be solved by factoring out method. As simple as that. Another simple question there, inequalities. Solve the inequality that. Now, in our lessons of inequalities, even in the document we sent you, basically explains different types of inequalities, and I gave you in the document and even in the lessons, I think I mentioned that every time we're solving an inequalities, first identify what kind of an inequality you're dealing with. That's the first step. So once you identify the type of inequality you're dealing with, it will be very much easy to solve whatsoever you want. So linear inequalities are always the simplest. This is a linear inequality. It's very simple to solve. There are absolute value inequality. There are rules to follow when it comes to absolute value inequalities. Rational inequalities, you have to look at some rules. Quadratic inequalities, polynomial inequalities, all those things. But this is the simplest one which we have there to say solve the inequality that. So here, inequalities are different from equations. Equations will give an exact value of x, but inequality will give a set of values for x. So we have that negative 6 is less than negative 3, x plus 5 less than or equal to 12. If you wish to, you can solve it as 1. If you wish to, you can separate it. This is a compound inequality, but solving it as 1, you still have the same thing. So this is just basically negative 6 less than, you break the brackets, negative 3x negative 15 is less than 12. So when you're solving it as 1, your aim is to make sure you just remain with the variable x in the middle. So first we delete the negative 15. The only way this negative 15 can be deleted is by adding a positive 15 to it, so that it can cancel out. It becomes negative 15 plus 15 is basically what? 0. So it means whatsoever I do here, I'll do everywhere. So I'm going to add positive 15 everywhere. Everywhere I'll add positive 15, so that we can have 15 minus a 6. 15 minus a 6. 15 minus 6. This is 15. Yeah. So 7 plus 7, that's 14. Hey! So 15 minus 6, that's a 9. Less than negative 3x. This is a 0. Negative 3x. Less than or equal to 15 plus a 12. This is 5 plus 2. That's 7. 27. Yeah. Sure, I can confirm. So that's what we have. So from there, we want to remain with the x. How do I remain with the x? Divide throughout by negative 3. So now, according to the rules of inequalities, what did we say? Every time we divide by a negative, the sign flips to the other side. So this means I'm going to have divide throughout by negative 3. We're going to have 9 over negative 3. The sign changes, faces this direction. Negative that over negative 3. The sign changes, faces this direction. 27 over negative 3. So that by the end of the night, we're going to have negative 3 is greater than x is greater than or equal to negative 9. That's our solution. Rewrite it in a normal way, starting with the smallest. This means negative 9 is less than or equal to x, and x is less than negative 3. This is your solution. In interval form, you can write it as x is a member of from negative 9 to negative 3. Negative 3 is not included, it's a round bracket. Negative 9 is included, it's a square bracket. This is your solution for the inequality. Very simple and straightforward. So we have another question there. But this time around, we are being told to find the slope of the equation y squared is equals to 5x squared minus y squared in bracket power 3. First task, before you do anything, breathe in, breathe out. Understand first what is the slope. In actual the other language, you're talking about the gradient. How do we find the gradient? So in such situation, if you see such an equation, automatically what is happening here is this question there must be, it must not be complete, it's not complete because we must give us a point. I think I've missed out a point. We are finding the slope for what particular position, for what particular point. Let me guys confirm from the question. So it's at the point 0, 0. That's the point we're dealing with. Okay, so now the easiest to handle this question is basically understanding that the slope, or maybe the gradient, easiest way of such complicated function is that we can obtain the gradient function by basically differentiating this function. That's one thing you have to know. So note that differentiating a function gives us the gradient function. So if I differentiate this, I'm going to obtain a gradient function which we are going to insert this point, then we'll have the slope. As simple as that. So now the question is y squared to be equals to 5x squared minus y squared power 3. So now what do I do in this case? Now what kind of a function do I have here? This is an implicit function. Why? Because y is not isolated. So if y is not isolated, y is not the subject, then what do? We differentiate implicitly. Differentiate implicitly. Differentiate implicitly. So by differentiating implicitly, we are going to differentiate both the variable x and y, but every time in this case we'll always give much respect to x as the more variable in the actual sense. So we'll differentiate both the variable y and x. That's what it means by implicit differentiation. We'll differentiate both the variable y and x, but every time we are differentiating y, we are going to add dy dx to the answer. But if we differentiate x, we will leave the outcome the way it is. So more respect is given to x. That's what it means. So we have this. What kind of rule can I use to differentiate this? Every time when we have let me say a complicated function like this, the easiest, I think, if you ask me, I can simply say logarithmic differentiation is the best when it comes to such complications. But still, even if you don't want to use logarithmic differentiation, here even chain rule can work. Chain rule works in a situation whereby this is a composite function. A function closed power something, then chain rule will basically come work around. So I don't know which one I can use here, but which one? Let me see. Which one can be faster? Okay, let me try logarithmic differentiation. I think it is easy. So applying logs on both sides. So I'm going to have the natural log of y squared to be equal to the natural log of 5x squared minus y squared power 3. we are using log differentiation here, so that power rule 2 can drop down. I'm going to have the natural log of y to be equals to 3 will drop down, 3 multiplied by the natural log of 5x squared minus y squared. Then next, what do I do? Now, let's differentiate implicitly. Differentiating the natural log of y. What do we do? Differentiate the input over the actual itself. So basically, differentiating y, if I treat y as a variable, this is basically 1 drops down 1 minus 1, power rule. So if this is y, I'm differentiating y has power 1. So the 1 will drop down and the 1 will decrease by 1. So automatically I'm going to have y power 0, which is giving me a 1. Remember, how do we differentiate a natural log? In the natural log, we differentiate the inside part, that becomes the numerator. So this is a constant, it will maintain to be 2. So if I differentiate the inside, the answer is 1 over the actual inside, which is y. That's how we differentiate natural logs. So it means the derivative of the natural log of y is basically 1 over y, because 1 is the answer for the differentiating y, and y is basically the actual itself, what was inside. So I have 1 over y as my outcome. So every time when you differentiate y, what did we say? We add dy dx to your answer, because this is the implicit differentiation. I go to the second part. So this is 3 is a constant. This is the natural log of this. What do I concentrate on? I'm just concentrating on the inside. Differentiate the inside. So 5x squared. If I differentiate 5x squared, 2 will drop down. As long as 5 becomes 10x, 2 minus 1, so that this becomes 10x. So here I'm going to have open bracket 10x, which is the derivative of 5x squared. If I differentiate y squared, 2 will drop down. This becomes 2y, 2 minus 1. So this becomes just a 2y. So this is negative 2y. But since I'm differentiating y, what should I add to this? I'm going to add dy dx to it. Because of the implicit differentiation, every time we differentiate y, add dy dx. Every time we differentiate y, add the dy dx to it. Over, how do we differentiate natural logs? We differentiate the inside, that's your numerator, over the actual inside. 5x squared minus y squared. This is what I'm going to have there. We are okay? And then, after doing so now, my aim here now, it is to make dy dx the subject. That's my aim. So, what can I do? My dy dx is the focus to make the subject. So I can write this as so I can write this as, okay, let me say if I have 2 multiplied by dy dx, this is 2 times 1 times dy dx, I have 2 dy dx over y in the denominator to be equals to 3 times everything in the numerator there. I'm going to have 10x, sorry, 10 times, this is 1 over 1, so 3 times everything to be 30x minus 6y dy dx over 5x squared minus y squared. Then what can I do? I can do some bad manners of cross multiplication from there, so that I can come and group some like terms. So I'm going to have this times everything, this times everything. So I'm going to have 2 times a 5, this will be 10 x squared dy dx, this times this to be negative 2 y squared dy dx is equal to y times this is 30xy, y times this is negative 6y squared dy dx. Then let's now group like terms. You can delete some on top. So I'm now going to group like terms. This can go to the other side. Everything which has dy dx, I only have these two guys, so they will all go on the left side. I'm going to remain with 10x squared dy dx plus 6y squared dy dx to be equal to, this side I have 30xy when this, what I made, oh sorry, all these are dy dx, so I still have negative 2y squared dy dx to be equals to 30xy. This is what I have in this question. This is what I have. Then if I factor out my dy dx outside, dy dx has been factored out, open bracket, here I'll remain with 10x squared, here I'll remain with plus 6y squared, here I'll remain with negative 2y squared, we close, is equals to 30xy. So that this becomes dy dx, or just from here, for me to remain with the dy dx, remember our aim is to make dy dx a subject. So we can divide both sides by this guy, 10x squared plus 6y squared minus 2y squared. The same maybe in this side, 10x squared plus 6y squared minus 2y squared. So that this can go. And I'm now going to remain with dy dx to now be equals to 30xy over, this is 10x squared, 6 minus a 2 is basically equals to 4y squared. This is my derivative function. Now the question is at the point at 0, 0. So this is the x coordinate and this is the y coordinate. We have to replace 0, 0. What do we have? That is the slope. So the slope is now going to be equals to 30 multiplied by 0 multiplied by 0 over 10 multiplied by 0 squared plus 4 multiplied by 0 squared. Automatically this is going to be equals to 0 over 0. Somehow, what can I conclude in this? This is something which is indeterminate. We cannot state exactly the solution. Somehow, because of the 0 in the denominator, we can conclude that this is undefined, or because of the 0 in the numerator, we can conclude that the answer is 0. So somehow I'm believing that in the preparation of this question, somehow they didn't prepare it well, but in such situation we can simply say that the slope is undefined. Since we have 0 in the denominator. As simple as that. So that is how basically we find the slope for this function. We differentiate to find the gradient function. After you find the gradient function, that function which is dy dx, come and replace your 0, 0 in it, that particular point you have been given in the function. Then you have the slope obtained. Let's look at the last question in this video, which says that for the function f of t is equals to t power 3 minus 3t squared minus 9t, use the second derivative test to find the local minimum and maximum. I'm sure the document for differentiation, explain the number of concepts concerning finding the local minimum and local maximum of functions. So we are going to solve this one. So f of t is equal to t power 3 minus 3t squared minus 9t. So the question is, what is the local minimum and local maximum using the second derivative test? First, step number 1, this is to find the critical points, critical values. And these critical values are found when f prime of t is equals to 0. So we're going to use the equation f prime of t to be equal to 0 to find the critical values. So it means prime, this prime means first derivative. So differentiate this once. So it means I'm going to have f prime of t will be equals to 3 drops down, 3t, 3 minus 1 squared, minus 2 drops down by the 3 upper to be negative 6, t 2 minus 1 to be 1, 1 drops down, 1 minus 1 to be t power 0, making this to just be negative 9. This is the first derivative, but you have to solve the value for t when this should be equal to what? A 0. So we have to solve for values of what? Of t. So obviously here the product is negative 18. Am I correct? 3 times negative 9 is negative 27. And the sum is negative 6. What are the factors? So the factors should be 9 and 3. 1 should be negative. This should be negative. So that we can have 3t squared minus 9t plus 3t minus 9 should be equal to 0, so that we can have 3 open bracket t minus 9 close. Am I correct? Yep. 3, no, this is a 3. Positive 3 open bracket t minus a 3 close. This is equals to 0. So that you can have t minus a 3 and t. What am I doing? What am I doing? What am I doing? This is what? 3t here. Am I correct? So 3t is common. We remain with a t. We remain with a minus 3. 3 is common. We remain with t minus 3. So it will be 3t plus 3 will be equals to 0. I believe I'm correct now. If I'm not, then I'm sure maybe it's because I zeroed. Yeah, so we have t minus 3 to be equals to 0 and 3t plus 3 equals to 0. So t is equals to 3 and 3t is equals to 3 over 3 over 3. This is negative. So t is equals to negative 1. So these are the critical values. So these critical values there, one of them should be a minimum, the other one might be a maximum. This is why we have to use the second derivative to show, is this one a minimum or a maximum, or is this one a minimum or a maximum. Okay, so let's now find the second derivative. So I can erase some up top. Okay, let me keep my values. My values are t equals to 3 and t equals to negative 1. This is my values. So you can delete some from here. Now let's find the second derivative. Step 2, find the second derivative. So the second derivative is f double prime of t. We are differentiating the first derivative now. So 2 drops down, this will be 6t, 1 minus 1, we have negative 6. This will just go away. We'll remain with 6t minus a 6. as the second derivative. So if that is my second derivative, then we'll use this second derivative to test if which of these is a local minimum and which of these is a local maximum. So what is the test? The test is as follows. If f double prime of that value is greater than 0, then T1 is a local minimum. But if f double prime of t is less than 0, then that value is a maximum. If any of this does not hold, if f double prime of t is equals to 0, then it is neither. That's the concept. So for t equals to 3, we are going to insert 3 in the double function, double prime. So f double prime of 3 should be equals to 6. 3 minus a 6, which is equals to 18 minus a 6, and 18 minus a 6 will give us what? Is it 12? Yeah, 12. So this is the value which is greater than 0. Therefore, t equals to 3 is a minimum, the test. But for t equals to -1, we're going to have f double prime of -1 should be equals to 6 multiplied by -1 minus 6. So this is -6 minus a 6, which is going to give us a -12. This is less than a 0. So if it is less than a 0, then therefore t equals to -1 is a what? A maximum point. As simple as that. That concludes our today's lesson. Thank you very much. See you in our next video.